think I started the recording.
All right.
Yeah.
So I know last time we recorded this session and we ended up putting it onto YouTube. We have a new YouTube channel called I think it's called IndyUseR. And so hopefully by the end of the meeting, I can pull that up, pull up a link of that and show you guys. I don't have any of the, I mean, it's still a work in progress as always, but feel free to, if you have comments on it or anything, we should have the videos up, and then for each video, we'll also try to add in a little, some links back to the Meetup group and that kind of stuff.
Yeah, in fact, maybe in the Meetup GitHub page, I can add the link to the YouTube channel and the abstract of the meeting. I can do that, and the link to slides too. Yeah.
Yeah. Sounds good. So Vijay, do you want to go first?
Sure. So I'll go first and I'll share a screen and we can start.
I think today we have two presentations. Vijay will have one on R trivia, and then I'll do one on the RENV package.
Okay. So can you guys see my screen?
Yep. Yes.
RStudio. Okay. So this looks okay. Yeah. Okay. So over here, I'm just going to do a couple of things. Okay. So this is where I'm going to work all the time, and I think all of you can read it right here. Right. So we'll just start with function right now. I'm just going to create a function. And we'll just do this right here. Nothing particularly interesting. Just right now, I'll just do this. And over here, I'll make a mistake right now. So x1 plus y11. This is a mistake. I just have this right now. And I do this, right? So now, first of all, what is f? If I was to type in f right now and hit enter, what would happen?
I think that you would get like the definition of f.
Yes. So definition of f. So f is right here. Is this compiled?
Not yet.
Not yet. So you cannot see this. If you type in any function, it says right here. So you see this ls is something that shows you, it shows that this is compiled and this is the namespace. It's kind of useful to be aware of what this is. Over here, it is not compiled. You can see this right now. F is not compiled. So if I call f right now, you'll get an error. So before we get this to it, what would this print? If I was to type in class f, what would this print?
Function.
Function. How about type of f? So this is an interesting thing. If you were to do this type of right here, it's a very interesting thing what R has. So R has all these things, and closure is a thing that R has. So right here you can see this. This function is a closure, and this closure is very interesting. So this is something that we should explore right now. So what is a function made of? If you were to just type this in right now, a function is made up of three things. It's made up of formals, its body, and its environment. So formals is everything right here. You see this x and y. So you can ask it question args f, and it'll tell you it's a printed form. And if you say formals f, it prints out what my arguments are, x and y, and you can see this. So that's what this formals and body is. So this formals is right here. You can see this formals and args. And if you were to type this formals right here, it will explain what this is. It says get or set formal arguments and stuff. And you can set it also right now. So if I wanted to do something right now, I could set things right here. I could assign formals something else right now. You see right here, it says formal. So if we can change it if we wanted to right now. Formals f, and we can say list x equal to 11 to 15 and y equal to 21 to 25. We could do this. and now f becomes different. You see right here. So f is changing. Does this make some sense over here? So formals is something that you can change function. This is very useful for certain things. But over here we have an issue right now. So let's try this out, right? And if I hit this enter, I've gotten an error now. Now how do we fix this error? I think we have discussed it in the past, and this is the body of it. So let's try to look at what the body of my function is. So body f, and if you type it in, it'll tell you this right here. And we know that there is an error right here. And how do I fix this error? So you might be tempted to go about in a different way, but there's an easier way to just do this edit F, and it'll open up a window. You can adjust it right here, and you can hit save and it'll do it. So right now you can just come in here and you can do this right now, right? And now F should be changed and you should be able to work and it should do correctly. I'll go back and set it back again so we can see this one more time. So this is one thing right here. And then let's look at F. Again, F is a problem. But over here, one of the nice things I think is when you get this, you can do a few things with R, which are not possible in many other systems. So this body of F is a list, or like if you think of it, if you ask it a question, it'll tell you that it is made up of 4 things. What are those 4 things? You can always ask it as.list and it will show you what those 4 things are. My 4th thing has a problem. So I can assign to body of F 4 quote x1 plus y1. And now F has changed again. Now you can do this, right? So it's very useful. You see how R is doing everything and it's allowing all of these things right here. I'll go back up and you can look at this and change it again. Now F is broken. Now here's one of the very interesting things about R. R allows you to do real-time debugging or like in-session debugging. And this is one of the nicer features of R that I like. So what does this mean? We can say debug F right now. You can just type in debug F. And what will happen is now it has an error and it got into it. So over here, this is very useful. And just hit help and you can see what will happen. So it'll go into this F function and you can hit next or step into. So I'm just going to hit N and it'll go into the next step, and you can see in the bottom right here that it's doing certain things. So over here you can ask it a question. What X1 is right now, it's not defined. When you do next, so it came into Y1 and now you know what X1 is. Y1 is not defined because we haven't gotten into it. You hit next and it comes to this portion right here. Right now if you hit next, it should tell you that Y11 is problem and you can get an idea. This debug works for everything. So if you were to do on this one, if you were to do debug LM, it would work LM also. You can debug and stuff. So this is very useful and very handy to do. If you call F again, it'll go into debug, which is something that you might not want, or you can just hit continue and it can go about right here. Right? Does it make some sense? If you want, you can also look up debug once. So here is a very interesting thing. So let's go and look into debug. So debug says these are all the functions. Debug, debug once is debugged. You can look at it. But then this is a very interesting function. So when you do debugging, this browser function, this browser is very useful. So whenever I write functions, I'll use this browser by itself all the time. So what it means is, consider this function right here, right? And now it has been compiled. You can see right here, right? This is compiled now. So if I was to write a function, right? And over here, what I generally do is I will just start a browser right here, just normally, and then you can do whatever you want with it. And then x1 times y1 or whatever we want, right? Over here. And then this is very useful in that now even if you haven't debugged, it is automatically in here. You can step into it automatically. Keep on doing this just to make sure that it is. And over here, you'll just find this out. And I will almost always have this browser in this portion right here. So this is very useful for us.
Yeah,
Debug.
actually, browser is something I find very useful when debugging Shiny apps. Actually, when I don't know what exact input is actually going into a function and stuff, I will put a browser statement and it will kind of show where the app is at that time.
Yes. So browser is one of the nice function, and Shankar, it is also very interesting for another thing. When you have an issue, right? So right now we are breaking into this portion, but there is a very nice thing in options also. If you go to options and look through it, there is a function for error. Like if you check this error, if we scroll down right here, right? So over here, it explains what you can do. You can do a stop, you can do a dump frames, or you can do a recover. So what I do is I use this recover. So right now, this F is some problem, right? Like, so if I call F, I'm getting some error. Right now, actually, we should have removed that browser thing from in there. Okay, let's finish this. So help. So how do I quit this? Okay, so F, whoops. Okay, I'm going to just, okay. Now, if you see, this caused me an error, but what you can do is, I'm going to just do toggle error, and this toggle error is just my function that I have written myself, and it's in my profile thing. All it does is it sets this utils recover, and this utils recover, what it will do is, it's very interesting. So now it has gotten into this browser and it tells me what function I'm in. So right now the call stack trace is only one, so I can just hit one right here and it comes into it, and now I'm in this debug session and I can look at what's going on. I can make modifications right here. So it's very useful to use this options and recover portion right here. Does it make some sense?
Vijay, quick question. How did you get from the uncompiled version to the compiled version? I think I'm missing that piece.
So the compiled version automatically compiles. So whenever the first time you run R, it will automatically compile. And there is a function like, so if you were to go and look at byte compile, so byte compile, not byte compile, compiling, I think. Let me see. Okay, so you see right here what happened also. If you see right here, whenever I do the toggle error, I'll get my whole stack trace, and you can do this. There is a way you can set it up that it compiles all the time, and I will have to look at it. Yeah, so comp function or compile, this is something that you can allow the interface to bytecode compiler. If you want to look at it, just look through this compile and stuff, and you can set up the different ways that you want to go. But if you don't do anything, you just call F and it'll automatically compile. That's how R does.
Thank you.
Yes. Okay, any questions so far? So on, I would search Roger Peng debugging R. He has a PDF which discusses many of these things, and he discusses also trace. So trace is another very useful thing, and it allows you to do things just like browser or recover. So trace and untrace is useful to be aware of, but any one of them, either you use recover or you use any of these things, right? So this is one of the things about functions that we should be aware of. So this brings me to the last thing about the R functions. So you see right here, it said formals, body. We looked at both of these and you can see that. Now this third one is very useful. So consider this right now. If I was to type in F and I will get an error and I don't want this, what I'm going to do is again go to toggle error and it'll stop my error thing. And right now, I'm getting some issues right now. But let's say in this one, I'm not using any particular values right now. And if you look at this environment of F, and it'll tell me that this is my global environment. Global environment is fine when we need to use global environment. But if you want to have certain things that keep state, then setting up state would be very useful. So consider this right here. If I'll just create a new function with x is 1 to 5, right? And on this one, we need to do something with x. So let's say I have a scale factor. So x times scale factor. So we'll just call it SF scale factor, right? And whoops, and we'll just see this. So if you were to now call, this will say SF not found. But if you say SF is 0.01, right? So now F1 should work. But I do not want to have the scale factor outside on my environment right here. So what you can do is, there is a very useful way that you can set up your functions which contain their environment. So what you can do is F is, you can see local, and what you can do is over here, this local is setting up an environment for your function. And on this one, we can say SF is, right now I'll just say 0.01, right? And on this one, we'll define a function now. My function is function x is 1 to 5, right? And on this one, x times SF, right? You close this, you close this, close this. And now if you look at F, so this is F still, but if you call F now, it works. And I'm going to do RMSF, and this F still works. The reason why it works is it has an environment, and this environment is a separate environment. And this is how you keep track of state. Does it make some sense? Any questions?
So by default, if I had the SF declared within the function f, then by default it's in local, correct?
Yes.
Right.
So if you have used ggplot for plotting, this is how ggplot sets up everything internally. It never sets your environment, and that's what it is doing. And this is the big portion of R that helps you out with this portion. Does it make some sense?
Lots of sense.
Yeah, and this is something that neither Python, like Python also has it, but it's not as easy as it is with R. But then also it makes R kind of complicated and difficult to debug certain things when you need it. So to see a good example, I would encourage you to look up local, and over here it has some very nice examples over here that they can explain also. So this is something very useful to think of, and they explain how this environment works. And this environment is how I have set up mine also. So if you see right now, I have a function called LSOS. If I call this, it gives me a list of things. But if you search on my thing, or you don't see LSOS right here in my thing, the reason is, if you do a search on my environment over here, you'll see that I set up an environment which has certain things in here. So this is number 21, and we can ask what sorts of things does 21 have. And on this 21, you can see these are all my functions that I want. So these are all some things that I have created. You should see that there is this function called LSOS, and then there are other things that I want in here that I've created for myself. It doesn't make anything interfere with anything else, and it does certain things, right? So all of this using all the things that we've discussed right now. There is nothing special, just these three things right now: formals, body, and environment, and that's what we did. Okay, that's all I had for today. Thank you.
All right. Let me just take a second to get set up here. And all right. Share a screen. that one. Okay. So today I'd like to tell you guys a little bit about a package called RENV. And first, I'd like to note that the RENV package is about it. It's about building a reproducible code that you can share with other people. So it's portable, it's reproducible. Recently, I've had the opportunity to use this in order to solve one of my problems, but you might have heard me talk about it at our last meeting when I mentioned there were a number of other talks that I didn't get a chance to really dive into, but I was really interested in. So this RENV one is one of those packages that I wanted to look at, and so now I've had an opportunity to use it and an opportunity to have it solve one of my most recent problems. So this is what we're going to be talking about um, uh, today. So REMV, it was built by Kevin Yushe, and if you go to the RStudio website, you can find his presentation on uh, the REMV package, how to build project environments, which I think is a great introduction to what RENV is all about and how it works. So if you're thinking like, what is RENV? You can think of it as a tool for managing your packages and your environments, right? So I don't know if you've ever been in a situation where you went to, or you started writing some code, and maybe you got a project, you had a project you were working on, you got your project complete, and then 6 months later, you go back to your project and you try to run it again, and uh, maybe RStudio says, hey, we have updated versions of source code or updated versions of packages, and all of a sudden your project's not working, or maybe even with the old version, maybe you've updated certain packages for other projects inside of your R installation, and now one of your projects is not working anymore. And so part of this is because when you're working on several different projects at the same time, each project may require a different version of a package, and if one of those packages gets upgraded without maybe you having a chance to run your old code, then the old code may stop working at that point. Right. And so I work in an area with dealing with test automation and writing kind of quality assurance tests. And one of the things that I'm always interested in is, can I reproduce the environment? Right? Can I, if I have a bit of code, what are the things that this code ends up depending on? What packages does it end up depending on? Maybe a specific operating system version. So recently, I was, well, not recently, about a year ago, I created this thing called a Docker image. So I was trying to write some test cases that would deploy a Shiny application out to like Shiny Apps.io. And so I built a Docker image, which is kind of like a little contained environment, and with an operating system and all my packages installed. And when I wrote that, when I put together that Docker image, I wrote a little script because I didn't want to list out, in my Docker file all of the packages that I wanted. So I just said, hey, let me write a little R script that would install these packages that I needed. So I just put all my packages into a list, and then I iterated. I felt proud of myself because I wrote a little R script. I iterated over every element of the list, and I installed that package into my environment, right? And then fast forward 1 year, because this thing had been working for about a year. Fast forward about a year, and there was a test case failure. And I was like, oh, test case failure. What's going on? Did something happen in my Docker image? You know, because I didn't, half of me didn't really trust the test. I was like, maybe it's my problem. And so I go and I try to rebuild this Docker image on my machine. And the thing, like my test case would not work, you know, and I was wondering like what's going on? Why isn't I'm getting I got an error, but it was a different error. And so I was like, what's going on? Why can't I reproduce this error that I'm seeing? And so that got me thinking about, well, maybe I can't reproduce the error because I'm using different versions of packages now. Like maybe the old version of the package was producing one error, but newer versions of the package were producing a different error. And so, so what I ended up doing is putting together a new Docker image with this RENV package. And well, I'll tell you about that in a little bit. But before I get to that, let me kind of go back and do a little bit more introduction of RENV. So we mentioned that RENV is all about managing packages. It does this by including something into your project called a lock file. And that lock file is just going to hold the names of packages, and it will also hold the versions of the packages and kind of where the packages came from. Right? I think those are three of the things that are inside that lock file. So there's kind of 3 commands that you should probably know about when you're dealing with RENV. The first command is the init function. So it would be RENV init. And that you use that to initialize your environment. The second one is RENV snapshot, and you'll use that to create or update your lock file. And then the
Rick,
third one,
Right.
yeah,
this Shankar here. I don't know if it is just me, but I'm still seeing Kevin Ushe's the video.
yeah,
Likewise.
yeah. I don't have slides for that part of it. So
Yeah, that's fine.
so
Just
we're
wanted
going
to
to go
make
through
sure.
some
Yeah,
of these commands together.
yeah. Just wanted to make sure it was not.
So we'll go. Yeah. So let's maybe I should just get in here and run some of these commands. So the first thing I'm going to do, all right, so the 3 commands that we're really interested in: RENV init, RENV snapshot, and then RENV restore. And so we'll show all of these files all of these functions in use. So I have 4 examples that I want to share with you guys of how you might add RENV to your workflow. So the first example, let's see. Let's close this one. All right, so let's imagine that you were just getting started with a project, right? You haven't written any code yet, but you're kind of fresh out of a meeting. They said we need to build a new project. We need to start a new project that does this. Well, the project is going to do my favorite thing to do whenever I have a new piece of code, which is build something called a spirograph, right? So so what I'm going to do is first I'm going to get in here and create a new project. And I already have a directory that I'm going to create my project from. So let me just go over here and find my directory. So I'm just going to create a new directory or a new project in this 01 new project directory. That has been, yes.
No.
All right. All right. So, so what we have here is clean directory. I only have a README file inside of it. And if I'm starting fresh with a new project, I can right from the beginning, I can just say renv init, right? So I do renv init. And what that's going to do, let's just take that down one more. What that's going to do is it will initialize my project with some REMV infrastructure, right? So the first piece of infrastructure that it will add is a lock file. And that lock file, it's going to go through all of my code. I don't have any code right now, so it's going to go through all the code, and it will say, what packages are you using? And all the packages that it finds that you're using that are also installed in your environment, it will add them to the lock file, right? So I don't have any code in here. So the only thing it says here, oh, I'm going to create a lock file, and I'm just going to put in that you're using renv inside of the lock file. And what the lock file looks like, it's just a little JSON style file here. And it lists out a little bit of information, what version of R you're using, maybe a list of repositories, and then what packages, like a dictionary full of packages that you're using. Second thing that it added to the repository is this renv directory. And so inside of this directory is some metadata that the renv package is going to use for uh, uh, placing other packages that it has to download and install. So now I can write my my code. So through the magic of command lines, we're just going to find some code here. Graph here. Oh, voila. Okay, so I've written this this piece of code, this bit of code here, and you'll notice that inside of my code, I'm using Shiny, ggplot2, and Plotly, right? So these are 3 libraries. I haven't installed these into my project yet, and even RStudio tells me, hey, I noticed you don't have these installed. Would you like to install them? So let me go through and install these into my library. So I'm just going to use my regular install packages, and then we'll just give it a list of things to install. Shiny, ggplot2.
It is saying that
Plotly.
because it did not find these packages in your computer, or is it because it didn't find it in this environment?
That's a good question. I want to say because it didn't find them in my environment, but I guess we're going to find out here in a second if it is really because it didn't find them on my computer. So when we install these, like I should have them on my computer because I think I went through this example before, and I've installed these packages before, right? But when we install this, if it's true that it didn't find it on my computer at all, then it should go out to the internet and download them and recompile them. And I'm on a Linux machine, and I already told you about my DSL woes, so that will be a very slow process. So let's see what happens here. So it's thinking. It's still thinking. All right. All right. So this was not as slow as if I didn't have these packages on my system at all, in which case I would have to go through and download and compile all of these packages. So what it did here was RENV under the hood, it has this thing called a global cache that it keeps for you of all the packages that you have previously like downloaded and compiled um, uh, by asking RENV, you know, in other projects that you've used RENV with, right? So if I didn't have these projects on my system at all or in my global cache, what would have happened was RENV, well, the install.packages would have said, oh, I need to go out to the internet. I need to go out to CRAN and find uh, the latest version of Shiny and ggplot2 and all the dependencies and stuff, right? But because I'm using RENV inside of this project, somewhere underneath the hood, RENV has intercepted this install.packages command, and it has said, oh, if you want to install this package, maybe I'm going to first look inside of my global cache for that package and the latest version, or whatever version came back from CRAN. And if I already have it in my global cache, then I'm going to just add a link to it inside of your project. I'm not going to try to install it again. I'm not going to try to download the code again. I'm just going to link back to my global cache, right? Does that make sense? Any questions regarding
But,
that?
but I'm wondering, wouldn't it be better, like, for example, I start a new project maybe 2 months later,
Mm-hmm.
that by default I might prefer for that project to get the latest version from CRAN or something. So I'm wondering whether that's the better default than uh, kind of going and looking for if it already exists for another RN project.
Well, I think it did. I think it did go out and look to see if you were getting like, if it had the latest version.
So both the version.
So,
Okay. So
right.
so
So
it
I
is
think we
checking that.
didn't.
Okay.
Yeah, we didn't give a specific version for this, and so by default, install.packages is going to say, I want the latest version,
Oh, and then it
and
checks if it already has it in the
so
computer.
I think
Okay.
right. And if it's because, so this is a huge time saver for myself, because Linux doesn't have pre-compiled binaries from CRAN. You know,
Okay.
so anytime I download a package, I gotta like compile it and
Mm.
have all the dependencies and all that stuff, right?
Okay.
But if I already have that, package, like whatever the latest is, if I've already compiled it once
Mm.
and it's sitting inside of RENV's global cache, then I can just refer back to the global cache, and I don't have to have multiple versions of Shiny. I mean, not multiple versions, but multiple installations of Shiny in
Okay.
each project that I have sitting on my computer. So if I have 3 projects that use Shiny, I don't need 3 installations of Shiny of the same version of Shiny.
Oh,
I
okay.
just need one in the global cache, and RENV will recognize that I already have the one installed in the global cache, and it'll link to it.
Oh, okay. So in that sense, this is different than Packrat in the sense that, because I think in Packrat it kind of copies, like for every Packrat project, the packages to its directory and stuff, whereas here it's
Right,
more efficient. Okay.
right. And
Uh,
so, yeah, go ahead.
I'm sorry, I was trying to follow along, play along as you were saying for
Mm,
my project. And it did create a folder called RENV, which I
uh-huh.
see on your screen. I go into it, and it gives me a folder called library.
Yeah,
In the library, I have my R and the operating system. If you go click into it,
yep,
right, and further into your
yep.
Linux, it gives me all the list of packages
Mm-hmm,
in there, and it has got all the,
mm-hmm.
as you would, if these are the package folders. So
Right.
it does, for some reason, Shankar carries the weight of the packages. I am not sure if you
Oh,
have
okay.
another project with another RENV, if all these folders would carry along. I do not know.
Okay.
One thing I would say to check out is let's look inside RENV library. Okay. All right. So one thing I would look is to see what kind of files are these, right? So it's hard to tell within the R GUI, but if you were to look inside your shell, I think you might see stuff like this, which is saying, what this is saying is that this file for vectors is a link. And it's a link from my current directory. I have a directory called vectors, and then it's linking back into the global cache, which is located in my home directory under local share RENV.
Okay.
Right. So I would check to see
Uh,
if the directory you have is actually listed as a link, and you can do that. I think if you in a terminal, if you were to say ls minus, I used AL, but I think if you just say ls minus L to long list the directories,
right.
then if it has a little L at the beginning, then that means that it is a link to another directory.
Oh, I'm keep reading that as a 1. It's a so I find something like -RW. I guess that's a read write.
Uh-huh.
-R dash R dash dash and 1 or
Okay.
L. I do not know how to read that. May I paste it
Okay.
in
Well, if
the chat window here to see if that helps?
yeah, sure.
Chat. How do I chat? Chat.
I think in the bottom,
Yeah.
yeah, there should be a little button for chat.
Yep. To everyone. Yep.
So, Derek, since you do a lot
Mm-hmm.
of testing, quick
Mm-hmm.
question: is Windows stable for per user files and stuff like? So right now it appears that you are storing everything in your .local, which is the
Mm-hmm.
XDG specification. I think is Windows stable.
For using RENV.
Uh, yes, kind of. See, the thing is, so it appears that what you guys are doing is very much similar to, like, what this RENV is doing is very much similar to NPM or other things uh, that they are doing. Like, they also have
Mm-hmm.
these log files. If you go and look into Rust, or you go and look into NPM, they create the same log
Right.
files and then they store the files in there. The problem is cache
Right.
invalidation becomes a big issue later on when you do a lot more things with it. So
Right.
it's just something that I'm not sure.
Mm. So I guess I'm not sure. So I don't have a Windows machine, and I'm not on the team that tests this kind of stuff. But so I can't say whether there might be problems with cache invalidation and that kind of thing. But I I know that in the documentation for RENV, um, they talk a lot about some of the gotchas, and we'll talk about that kind of after all the scenarios. There are some gotchas or some things to watch out for when you're using RENV. Um, uh, One of the things to note is that on Windows or on any machine, if you're asking for an older version of a package that may not have a binary available on CRAN, then you're asking your users to actually compile that package. And some systems don't have all the tools they need to compile. And so RENV has a couple of functions that would help um, with downloading the tools you would need in order to compile the packages. But as far as like dealing with uh, what would happen if maybe something changes with one of the packages that you've already downloaded and previously and compiled. I'm not sure how RENV handles that, and I guess I'm not sure if I can think of a situation where just off the top of my head um, where you would have like maybe a package gets a package with the same version gets reissued, but maybe that's where the hash value comes from, you know.
Yes, and so Derek, I'll tell you, one of the things is
Yeah.
like I also use this, and one of the things I think is Rust does a very nice job of using hashes and stuff internally.
Mhm.
These log files, I really like the idea of log files and stuff. What you guys are doing, or what
Mhm.
RENV is doing, or our studio is pushing, is you get an idea of, I like Docker, but I don't like the way of using Ubuntu latest. We should do Ubuntu 18.04 with a hash so that it can run,
Yes.
because Docker is
Yes.
also not a stable, man. Yeah.
Right.
Yeah.
Right. And that's one of the things that I'm also interested in, is like when you have a Docker file, list out some version or some date timestamp so that you're always pulling the same Docker image, you know. So what we were talking about just a second ago was inside of this lock file, you'll have something called a hash, and this hash can be used um, to tell whether the package that you or the lib let's see the source code or the binary that you are downloading is um, is the same as what the previous developer was intending for you to download. So um, let's say that the RENV package for version 0.9.3 was re-released and it had a change in it, then this hash would not match the hash of the new source file that you download, and that might cause the global cache to, depending on how the developer wrote it, they might say, oh, well, we need to invalidate all the version that's inside the global cache for 0.9.3. We don't actually have a good version of that. We need to now download the new version and recompile it. Or maybe they just give you a message and ask the user what they would like to do. Because for something that I guess for stuff that should be released with version numbers, you would think that re-releasing a version number is a little suspicious. So. All right, so just a message from Shri. It looks like that was so it
That
looks
was
like
a link,
it is a
and
link. Okay.
Shankar helped me. Thank you, Shankar.
All right. So so in this first example, when you're starting from scratch, you can install your packages. And then, so what we see here is that all of these packages, I already had them in my global cache, so it's nice and fast to get them installed on my system, right? And um, now that I have these installed on my system, see, let me go back up to here. Should be able to run my application. And we get to see a great looking spirograph. Are you guys familiar with spirograph? This is one of the fun tools that, yeah.
Yeah, I always find it
When we
fun every
were,
time you show it. Yeah.
yeah,
That's cool.
I used to just change these and get little designs. All right. So, so now I have, you might notice that I have this RENV file, and it still hasn't been updated. Even though we've installed new packages, those packages are not listed in the RENV file. And so this is where that second command comes in. I can say RENV : snapshot, right? And what this does is this is going to go through all of my source code files, and it's going to check to see what packages in the source code files am I using, right? So, and once it finds out what packages I'm actually using, it's going to list them out for me here. So I'm using there's a lot of packages I'm using. And then it'll ask me, do you want to add these to your lock file? And I'm going to say yes. And now our lock file is updated with all the packages that we just added, right? They're all going to be in here. Any questions on this first scenario? Just like getting started with a clean project, how you can incorporate RENV into that project.
So far, so good.
All right. All right. So let me take you on to scenario 2. And this might be the scenario that most people are in when they first want to start using a package like RENV. So just going to go over here to a project that I already had open. Let's say I had developed my spirograph code. Here it is in all of its glory. And hopefully when I run this thing, okay, it just starts up. I've got my spirograph here and it works. All right. And so now kind of coming in at the end of a project or in the middle of a project, I'm thinking to myself, oh, I really want to capture what packages I'm using and the versions of packages I'm using, because I know that Spirograph works very well with these current packages that I have. And so in this scenario, what I would do is I would say RENV : init. So we're going to initialize this project with RENV, and that's going to give us the two things we had before, which were a lock file and our RENV directory here. But it did something else kind of behind the scenes. So let me just pull this down. What you'll see is that it also went through all of the source files, and it automatically figured out which packages I was using inside my source files, right? And so it listed it out here. And then at the end, it created a lock file with those packages already listed inside of them, right? So now I have my lock file, and it has all my packages kind of listed inside. Now, if I had a package that was installed in my environment, but I wasn't using inside of my source code, then that package would not be included in the lock file, right? So let me, I wonder, I don't think I saw mass in here. Oh, mass is in there. I don't, maybe R markdown wasn't, let's see, just checking QR. Yeah, I don't see R markdown. Let's install .packages R markdown. All right, so we're installing a package that we didn't use inside of our source code. I do have it available inside of my global cache. So you see it going through and getting all those files, all those extra files from the global cache, and installing those into my current environment, right?
So, Derek, quick question.
Yeah.
Is the install.packages rerouted for the RENV when you do the load? It appears that that's what it has done.
Oh, can you say that again? It appears that the install.packages is
like, so RENV has modified install.packages where it does certain things differently than the regular install.packages. Is that right?
Yeah, I'm not sure how they did it, but I think that it has hooks to maybe some lower level functions that that install.packages uses, because there's a number of ways, I think there's a number of ways that you can install packages. And I think the idea that the RENV package had was, let's try to make it as normal as possible for people to install their packages, so they don't have to use any special functions to install packages, but we will try to intercept those calls so that when somebody asks for a package, we'll first check to see if it's in the global cache or not. So there is, I think there is some kind of interception of messages going on there. Anything else?
Nope, thanks.
Okay. All right, so I installed R Markdown in here, and you saw that it pulled in like quite a few extra packages to go along with it. So now, if I were to do this this R snapshot again, RENV snapshot, if there's any new packages that are used by my code, then those would get added into the lock file. But anything that's new in the environment that I'm not using inside of my code, or if really the thing is, if RENV can't figure out whether you're using the package inside of your code, then it won't include it in the lock file. Right. So the idea behind the lock file is that it's really just supposed to be the packages that are needed by the source code. Right.
So
And
even if I say a library R Markdown in your spirograph file and not use the R Markdown file, then
let's try
not.
it. My guess is that it will include it at that point. Okay, so let's save that. And then let's run this snapshot again. Oh, so now it's ready to add those functions to the lock file.
Okay.
So I think it's looking for just you like even including it into the file. So not necessarily using it, but even the inclusion of it, even you just mentioning it is enough.
So Derek, can you say no on that one and then delete the R Markdown and go again? And delete the R Markdown and let's see what happens. Thank you.
So
Beautiful.
yeah, when it went through that source code file, it did not see any references, I guess, to it.
I'm guessing it'll be the same if I call the package using package name : even without explicitly calling library, just like how would Packrat would do, right?
Mm.
If I said R Markdown : something in my code,
Yeah.
and
Which I
without
don't know.
explicitly saying it's a library, I'm hoping that the snapshot would
I wonder if there's
update
an
that.
easy function to call for R Markdown inside of there. I don't know. We could just call it draft or find
Yeah.
external resources or something.
Yeah.
All right, let's try that. So given R Markdown document, you might have to have an input. Well, I guess we're not compiling it, so hopefully maybe it won't care. All right, so let's do that. And then snapshot. So it still sees this as a reference to the package.
This is super nice.
So there are some, I think there's a whole section of like limitations that they outline very nicely on the package's website that say like if you do things like what I was doing originally in my code, which was put your packages into a list and then run that through like a loop that does install.packages on, or maybe just says install.packages all these, then and you never use those packages inside of any code, then it would not add them to your RENV file. Right.
Super nice.
All right. So now you have an renv.lock file. And so let's move on to the third scenario, which is we've showed you how to kind of incorporate renv into your project. Now, let's say you wanted to share your project with somebody else, right? So how would that work? So let's go to example 3. I think this is it. All right. So in this example, we have our spirograph code here. We have an RENV file, and then we also have like some regular project stuff. And the way I think the idea behind the RENV lock file is that if you want to share your project with somebody else, then you all you have to do is share the source code along with the RENV lock file, right? And so if you're thinking, well, what are some good practices for sharing these types of files? Just putting the RENV lock file into a source code repository along with the rest of your source code is enough to get people started with using the same versions of packages that you intended for them to use. Right. So let's say that your friend had put together a project. They've they put their source code into a source code repository, and they also included this RENV lock file inside the source code repository. What you can do is you can download a local copy of that repository, and then once you get into your R session, you can say RENV : init, and it will go through and restore the R packages and everything for you. So if that means that if you need to download and compile the packages, then it will go through and take care of downloading and compiling the packages. So I think on my system, because I already have the packages in the global cache, it was able to find that. And I think if we go in here into library, let's see, that's not going to work out because it only found, I guess it only did one. It only kind of reinflated one of these. So let me go back a little bit here. I have my spirograph open. All right, so there's another command, renv : restore. So now I think it is, maybe you have to run this restore command, but now it sees that there's a bunch of packages that I need to install into my environment. So I'm going to say yes, go ahead and proceed with installing those. Okay, so now it has kind of restored all the files from my lock file. And if I go into the library, okay, here are all the packages that we originally had. And you can see up here, it just grabbed all the stuff from the local cache and it linked to it. So I already had all these things installed. But if you didn't have them in your global cache, then you would need to like download and compile them.
Derek, I have a
Yeah.
question about the integration with Git. Does this take into account that you have Git, or it's not going to honor it?
I don't think it has any. Well, I guess, are you talking about whether you have packages installed through Git?
No. So
Or
see,
are you talking about just that your project is located in Git?
so the way I understand it is like this RENV should automatically get into the .git ignore automatically. If I have .git ignore, it has to get this renv folder into that git ignore, and the renv.log doesn't have to, because I have to keep track of this log file. That is for sure. But this renv will keep on changing, and if I already have git as a part of my system and I'm using it and I do not keep track of it, and then it is, so does it know about git? If, see, the thing is, people
Um,
are more going to be aware of git, not of
Mm-hmm.
renv. And
Mm.
does it behave sanely? I assume it is going to behave sanely,
Mm-hmm.
but I'm just asking what you, like, your experience is.
Um, let's see. I uh, I'm not sure how to answer it because I feel like I have a special relationship with git ignore files. I think a lot of people like git ignore files, and I kind of find them a little bothersome because they always ignore the files that I want to know about, um, files that I really want to delete from my system usually.
um,
Um,
I just quickly tried out an existing project
uh-huh.
as you were walking through. The first thing it did was it gave me a warning saying that this is going to be a one-time warning,
Uh-huh.
and it is going to um, make changes to my git ignore file.
Ah.
When I went in to see what it did not do anything other than other files that I had already had in there.
Okay.
However, within the renv folder, there's another git ignore file, which has got
Ah.
library Python staging directories. Oh, you
Yeah.
got it on your screen there, right?
Yeah.
Those were the addition. So in my
Okay.
project, there are 2 git ignore files right now. All right.
Okay.
So I am glad that the log file would be not ignored and be able to be committed and checked in.
Mm-hmm.
I am not sure how another git ignore with works here and with the
I
other git ignore file. So that's
I
something
think
I need.
I think the way get ignore works is that depending it'll I guess all of the things that it ignores uh, can be relative to that get ignore file. So in this case, we have a get ignore file in this directory, and it is highlighting folders that are at the same directory level. So it's saying the library file, the staging file, if there was a Python file in here. And then in each of these, you could also, or in any other directory, you could have another git ignore file. And so the git ignore files kind of build on top of each other and saying, as you work through the directory tree structure, any git ignore files that get finds along the way, it will honor them for folders that are below, that are at the same level or below the git ignore file.
Makes sense. Makes
So
sense.
maybe that's why at the top level it didn't make any changes, but further down it has said, okay, starting with this directory, the renv directory, um, start ignoring these things. Because you certainly could have taken these elements out of this git ignore file and moved them up to the top level git ignore. But then I think things get a little hokey because you have to be very specific about the path, the directory path names. You know, you either have to use some kind of regular expression to say I don't want the library if it is underneath a renv. I think it's a lot easier to just put the .git ignore file in the directory where the thing is going to be ignored.
That makes super sense.
You know, cargo, which is the Rust thing, when you do a cargo in it, it automatically will create a Git directory, a Git repository and stuff, and it does it.
Mm.
So when I do a renv in it, does it do a Git repository initialization when I do a thing if it doesn't have it already?
I do not think so.
Okay.
I think they, my guess is that, you know, I haven't tried it, but I didn't read anything about that kind of feature in when I was reading through the documentation for it. I haven't heard any or read anything that would lead me to believe that it does that it
Well,
initializes a Git repository.
the reason why I'm asking Derek is I'm used to using Git, and the thing is, so when I do Git in it, I have to issue that command on the command prompt or shell or whatever
Right,
I'm using. When I do rev in it, I have renv in it, I have to issue it in an R session. And these
right.
are things that you and I will do it because we are used to it and we are proficient enough in it. But when I'm
Hmm.
teaching to students or stuff, it is very complicated and they will get
Yeah,
confused and stuff. So that's why I'm asking you these questions. I'm not trying to hassle you or anything, man. Sorry.
yeah. I think there is so um I haven't used this too much, but I think that there's a library from like the tidyverse team, and I think they call it like use this. And
Yeah. Right. I
inside of
like
use
that
this, I
one.
think that there is some functions for creating Git repositories.
Yeah. And I like the use this
Some
much
are.
better. Yeah.
Mhm. And that might be one of the reasons why that kind of feature would not appear inside of this package, is because there's already a function for it inside of use this. But it is interesting that, like, I think with Rust, you were saying that they kind of say, if you create a repository, if you create if you initialize an environment for working with Rust, we are automatically going to give you a Git repository, because I think that's one of those things that kind of helps to enforce good coding practices. You know, to say, you're going to have some code, and you're also going to get a source code repository to go along with it.
Yes. So, I'll just tell you, Derek, the way
Mhm.
Rust does it is we are going to do certain things like whenever we are going to build stuff. So, like, this
Mhm.
renv directory is not something that you would want to have it in your git ignore file. So, whenever you do a cargo init, it will do certain things. It will create a git ignore file
Mhm.
and it'll set it up for at least Rust correctly. It will not set it up for anything else, but at least for Rust, it will be correct. And you have something going, man, like which is better
Yeah.
than nothing, man. So I think, and I like this renv,
Mhm.
and I'll just look into it a little bit more. So
Yeah. All right. Uh, okay, so one last thing about using renv dot lock file and placing it into your source code repository. That one of the upsides of the advantages of having it inside the source code repository is that the source code repository now becomes the kind of like the source of truth of what packages and what versions of packages are needed for the code. And so if somebody adds a feature that needs a new package, then they can update the renv file, renv.lock file, by calling the snapshot function, and then push that change to the lock file up to the GitHub repository. And when other people need to get the latest version of code, they will just download it from the repository. So it's a great way to kind of share that lock file. All right, so the last example that I want to show has to go back to that story that I was telling you in the beginning, where I was creating this Docker file. And so with this, let me just, actually, let's go in here. So I'm going to go up one, up two. So here I have a directory, and it has, actually, maybe it's easier to show in here. we'll just go up a couple directories, go into this one here. All right, so in here, one thing I try to do is I try to create these Docker environments that have versions of R installed within them and a bunch of packages, because oftentimes I just want to run code with a version of R and some packages. So what I can do is, once I have a lock file for a specific project or something like that, I can then create a Docker file. And if you're not familiar with Docker files are just files that kind of list out some instructions for compiling or putting together an image, something called a Docker image. And it's just an environment with an operating system and a bunch of software installed inside of it. So here, I am using the Rocker image, R version 3.6.2. I'm installing some system dependencies, so that's not super exciting. But down at the bottom, you can see how I'm installing RENV, and then installing a specific version of RENV, and then I am copying my lock file into my Docker build environment, and then I'm running this RENV and restore command. And if I want to get a Docker container that has the same packages with the same version of those packages put together, all I have to do is include my RENV file and run RENV restore, just like I did if I was checking out the repository, right? So when I build this Docker file, I'll get my whole environment set up to run my spirograph program. So one other scenario that was a little bit trickier than this, for the example that I was telling you about when we first started, where I had my test case, in that case, I wasn't including any code inside of my Docker image, which made it a little tricky to create my RENV lock file. So what I wanted was an RENV lock file that had a bunch of packages in there, but I didn't actually have any code that used all those packages. And so when I went to create my snapshot, I had to use this function. I think it was snapshot simple. There's like a simple, let's just look it up, RENV snapshot. There's this type parameter, and the type determines what kind of snapshot you're looking for. And most of the snapshots are, they're doing the smart stuff, like looking through the source code to figure out which packages from the environment that are really needed by the source code. But there's also this type, here we go, snapshot types. There's also this type called simple. And the simple type just takes all the packages from your environment and puts it into the lock file, right? And so that's what I ended up needing in order to get my Docker, in order to get a lock file that I could then install inside of my Docker image. For the scenario where I didn't actually have a program that used all these packages, I just wanted to install packages into the environment and get them into a lock file. So I think the last thing I want to talk about are some of the gotchas for using this, and these are pretty well documented on the website. I would say, let me show you the website. They have great documentation. I was reading through it, and it really helped me with getting these examples together. But one of the gotchas is that RENV tries to track where packages are installed from. So if you have a package that's installed from a GitHub repository, then inside of your RENV file, I think it will list out what GitHub repository that package came from, or maybe you installed it from a tag in a GitHub repository or something like that. If it can't figure out where the package came from, then RENV will probably fail. Right. So if it can't find it on CRAN, or if that lock file just doesn't give enough information to tell where the package came from, or even if I think if when it's trying to create the lock file, it can't figure out where the package came from, then RENV is probably going to fail at that point. We talked about earlier, if the package was installed from a CRAN binary and that CRAN binary is no longer available, then RENV will try to install the package from source. And if the user does not have the correct libraries, the correct system level dependencies to compile that code, then RENV is probably going to fail in that case as well. Right. So I think those are two of the major ones that that they mention on the website that I thought were probably worth mentioning. So just to kind of wrap up, if you have, I guess, questions about RENV, you can always shoot me an email and I can look into it. Or there's lots of documentation, a whole slew of articles about how to use RENV. And there's also the Kevin's presentation from the conference, which is a helpful kind of overview on different scenarios in which you'd want to use RENV. So, are there any questions I can field?
Yeah, this was a great introduction to the package. So, do you have a sense of? So, is the plan that kind of, for future projects, kind of the recommendation is to use RENV instead of PackRat?
Yeah, I think that from all the senses that I can get from documentation and presentations and stuff like that, is that RENV is kind of positioning itself to be the successor of PackRat. If you ran into problems using PackRat, then I think people are going to start saying, hey, you should look into using RENV.
Oh, okay.
So I had previously tried out using PackRat with some of my projects, and I didn't really stick to it very much. But I think the more I learn about the more I learn about how these tools work, the more I the more I write code that I want other people to run on their systems, without where it's very important to have a specific version so that I'm not playing the system administrator for them for their system. The more I start to use these types of libraries, and so I know for a lot of my Python work, I started using a library with a similar purpose called pipenv, and so I'm definitely in the like a fan of this package.
And it feels much lighter. If I have to git push my project, then I have to carry around the PackRat files, right?
Right.
This feels much lighter with the log file.
Yeah, I thought in a previous lifetime, when I had put together a project that used PackRat, I thought this could be this is like rampant, put the label on the video, rampant speculation. I thought that they were encouraging us to commit the whole, like all the sources and stuff, to the repository. Did anybody else get that sense?
Yes, I thought
Okay.
that was either a post by Kevin or a video way back when on PackRat.
Okay.
The guidance was to check the entire repo with the PackRat folder in there, or have the bundle separately checked in. Bundle everything, check in just the tar file, so somebody else can check out and unbundle it. So
right. So yeah, I also agree. Like having just the lock file and then using a local cache. It I think that there are some. I think if you're running on Windows, then it may be a little bit harder because of the way the extra tools that need to be installed for Windows in order to get some packages compiled properly. Um,
So, I have a quick question.
yeah,
I don't understand why we need RENV in the first place.
mm,
Like, I understand Packrat because Packrat was version specific.
yeah,
If I do install.packages, if I don't have administrative privileges, it will automatically install in local versions. This is one extra in direction, and we are all technically savvy here.
mm,
Considering 8 people who are sitting here or 7 people, we
mm,
can manage all of this. The other people, I'm not so sure. And this is adding one more thing, man. Like, so I understand it, I support it, and I'm going to be okay with it. But
mm,
it's just something, getting people to use Get is complicated,
mm,
and then getting someone to use RENE on top of Git is not as, like, I'm not sure, man. Like, so
mm.
this is something I find, and this is my observation of it. So, and I'm sorry that I'm a little bit skeptical of it.
No, no. I think critically thinking about the use cases and the way that people are going to be asked to interact with it is important. Um, for myself, one of the things that I think is a difference between using RENV and using and just installing things into your local store of packages is it might be the versioning. So you'll I could be totally wrong on this because I don't truly understand under the hood. Like when you ask, like if you're not using RENV, when you ask for a package to be installed, like you don't always have to install it into your global version of R, into where all like where R is installed on the system. You can have packages installed kind of somewhere into your home directory. But I kind of wonder what happens if you ask for a version of, uh, well, if you ask for multiple versions of the same package. Um, does that installation in your home directory, um, does it handle multiple versions of a package?
No. So, Derek, I'll tell you, I agree with you
Mm,
100% on this one. Multiple versions of the packages doesn't work. And the complication of R is it is so dynamic that, right now, when you typed in library R markdown, you can figure out a little bit. When you type down R markdown colon colon, then you can figure out, okay, it needs R markdown. But if it
mm,
was part of a string and thing, I do not know for sure whether this can look into it. And the reason is because of the dynamic nature of R.
mm,
I'll tell you, I am used to using a lot of static languages. Static
mm,
languages can do lots of things that dynamic languages cannot do certain things. And if you look at it, Conda is for Python, right? Like Anaconda. Have you seen how
mm,
Conda does it? You have to type in Conda update, and they do this thing, and they have a very similar system, and they do virtual environment and stuff. But
mm,
look into Python's ecosystem, and you will find that it is a big mess. Like, I do not
mm.
know if you follow XKCD. XKCD has this thing about the mess of packages, and
Yeah,
I'll right now share it with us so we can look
yeah,
at it.
yeah,
And we are heading in that direction, I think. So
mm,
that's just my thinking of it. So
yeah. I think this is the one with all the arrows that asks a bunch of questions and stuff.
yeah, I'll share right now. Hold on just one
Okay.
second.
Okay.
Yeah, so I am just now sharing it with the group in the messages. If you look at this XKCD comment strip, you will see what I'm getting at. The thing is, what happens is, when we do lots of environmental stuff, the way R is being done is it will do default in the system, but if you don't have system, it will do it in home. Right now we are trying to do
Mm.
in direction, which makes sense if we are developers. As a user, it doesn't make as
Mhm.
much sense to me, if that is any way to think of it. That's how I'm
Mm.
thinking.
Aren't these tools meant for developers? Yeah. Because we're sharing projects so somebody else can help us debug, uh, pick up the
Yeah,
project
of
and
course.
so on. So
I agree. But see, one of the things is, I'll tell you, the open source movement is not about only developers doing it, is the democratization. One of the things is when we put in tools in between, right? Like, so how does it interact with Git? This is something we have to think. All of us over here are going to work through this. I have no
Mhm.
question about it. But a young student who wants to do certain things is going to have difficulties. So right now, I was reading through the things when we were going through, it is intercepting install.packages. So you know
Mm.
how much difficult it's going to be for anyone who's teaching this to interact how to use R in env. I try to teach R, and if
Mhm.
someone does it, how am I going to debug it? I don't have the resources of R Studio, and this is what I'm trying to get at. Or like,
Mhm.
just think about it a little more, and R Studio is certainly helping us get R more accessible. So it's just something broader to think about.
Mm. Are you worried that they might run a command and under the hood it's being intercepted? They might run the install packages command, and under the hood, like, you expect install packages to do one thing,
Yeah.
but under the hood, because you've now used renv, it's actually doing something different. It's doing
Yes.
this extra, go to the global cache, check to see if you got it there, then come
Yeah.
back kind of thing.
So I'll tell you, Derek, one of the things I'll say this, right? Like, so not
Mm.
even just someone doing it, but let's say one package decides to use RENV internally. And then if it has captured, then it is very difficult. Like, if you do library functions, like when you write
Mhm.
library in certain, if you don't have the order correct, it can really mess up your things. And R is very
Mhm.
finicky about this. I will not change anything in my R script. 6 months later, it just doesn't work. And I'm like, man, I didn't change anything here. And why did it stop working? And this is just something that I'm a little worried about right now. Yeah.
Yeah, yeah. I think it's good to bring these concerns up, because I know for myself. So if you would have asked me before RENV came out, uh, do we need something like RENV? And I would have said, oh, we have PackRat, don't we? You know, and but then, the more I talked to people about PackRat, the more I started hearing that they had problems with PackRat. And I was like, I've never experienced any of these problems that people are talking about, but that could just be because all of my use cases for PackRat are very simple, you
Yeah.
know. Um, but when you start to get into the more complicated use cases, some of these problems start to become more apparent. And so,
Of course. I don't have any doubt. In fact, I think RENV is much better than Packrat, but it is
mhm,
much more better for developers or people who are doing testing and who are so used to, when you said so many things, even in our group, we were so used to thinking of where to issue these commands. And this is something
mhm,
that we take for granted. I'm in this teaching thing, and when I want to teach stuff, right? A student trying to do this on a Mac or a Linux computer is so much different than Windows, man. Like, when you do
yeah,
like GitHub install also, or that dev tools install,
yeah,
works so much better on Linux and Mac than it does on Windows, man. So
yeah,
I just like, I feel for myself, man. Like, I have to teach this and stuff. So sucks for
yeah.
me. Yeah.
Do you end up running into a lot of like, the environments that you guys are using for teaching, are they Windows environments,
Yeah,
or
man.
is it?
So most
Okay.
of us is Windows environment, and we do not have access to install. So Dev Tools is one of the things that we cannot install
Yeah.
because it requires our Dev Tools or other things. And I made a mistake of not telling to my IT people, and I have difficulty getting that GitHub install and stuff. And I tell
Yeah.
students, just run it on your laptop or your own personal desktop. Don't run it on a VPC system and stuff. So,
Yeah.
yeah.
Yeah. I think there was I saw one video um, where they were talking about um, uh, like I never knew, I think before last year, I never knew that there was, that people were having such problems on Windows until I saw this video where they were talking about some of the fixes that they had made for things and kind of showed what the experience was. And I was like, oh, there's a whole different tool chain for compiling things on Windows that, that I was not aware of, you know?
And I'll
So,
tell you, the Windows stuff, compiling on Windows is even more finicky, man. Like getting R working is
yeah.
finicky, but on Windows, it's even more finicky and stuff, man. Like, so when R version changes and stuff, you have to be a little careful and stuff. So, and
Mhm.
I face this issue because when I'm teaching students, they'll ask me questions, and it is not their fault. It is something
Mhm.
that has changed in either Windows changing or R changing, and this is just something that I find a little more complicated. So novice, but no one here is a novice, so I'm okay with our group. I'm just stating it if we
Yeah.
wanted to teach people and stuff. So
Yeah. Yeah.
Derek, I enjoyed the talk. Thank you.
Yeah. No
Yeah,
problem.
yeah. Thanks again for the talk. Nice examples of different types of use cases. Yeah, great. Thank you.
All right. So at some point over the next couple of weeks, we'll throw this up on the YouTube channel. Remember,
Yeah,
if you do a search for IndyUseR,
yeah.
so
And
let me
I'll
just
also
pull
I'll
this.
also put the link to that in the Meetup page and the GitHub page, so that way people can get
Yeah.
to it. Yeah.
So capital I Indy, capital U, capital R, and hopefully it shows up as a person, and we'll be working on updating that as well.
Yep. Cool.
Fantastic.
Yeah, thanks for
All
doing
right.
that also.
Yeah, no problem.
Yeah.
Thank you, Dave.
All right. I guess we'll see you guys next month.
Yeah.
All righty.
Let's see
Yes.
how the situation is next month, whether it's still virtual meetup or
Yeah.
not.
Yeah.
We'll see.
All
Okay,
right.
everybody.
All
Bye.
right.
Stay
Talk to you
safe,
guys soon.
everyone.
Bye.
Thank you.
All right.
Bye.
Bye-bye.